thank you for everyone to be here. We will talk about how to make your process FMEA more efficient. We will give a few tips about that. Okay. What are we going to cover together? First, I will present to you the application case on which we will base our presentation. It's a direct current electrical motor. Second, I will just remind for everyone what is the process FMEA method, what it is, what it does, the way it works. Number three, what are the savings that are possible when we use the process FMEA method? Number four, it was the topic of this webinar, how can we make it more efficient? So I will share 3-4 ideas that are really important to consider when we want to make process FMEA more efficient. Then I will talk, for those of you who know the automotive standards on process FMEA, I will describe how it allows to make more simple the reuse and update of generic process FMEAs. Okay, so these are the 5 steps of this webinar. So let me first present the product and the process on which I'm going to base my presentation. The product is actually a direct current motor. So a direct current motor allows to transform electrical energy, let's say, into mechanical energy, to transform electrical current into rotation movement, of course, right? So the way it works, you can say, is what is shown here, right? We have electrical cable here that allows to provide electrical current. You see we have some angular sectors here, and here, that transmit this current to some coils, the coil that is here. And the fact that we have a current going through these coils creates a kind of magnet effect. It creates a south and north, let's say, magnet. And then we have on the side here a stator part on which we have some magnets that are mounted as well, right? So of course, when you have 2 magnets, they either attract each other or they either repulse each other, let's say, right? So due to the current, it will create actually a mechanical torque and the motor will turn, right? And then, of course, in a real motor application, we have something much more complex than only one coil, but we still have the electrical contacts that are here that send the current to many different coils, of course, and this allows actually the motor to rotate, okay, like this, okay? So, okay, this is the way an electrical motor operates. So the product on which we will work is this electrical motor. Here you have it assembled on the left, okay? Then you have the different components. So we have a stator in which we have the static magnet. Then we have the shaft, which is shown here as well. You know, the shaft is shown as well here, right? On the shaft, we have an armature. Then we have the electrical sector that I just presented. And then we have the coils that allow to create the electromagnetic force. Then we have a rear cover, which is the plastic part, on which we have some the electrical contacts that are going to touch actually the angular sector and transmit actually the electrical current to create the torque. Okay, and then we have some bearings, of course, to guide the shaft in rotation. So this is the way it works. Let me show you, well, I will show the manufacturing process just in a few moments, okay? So the first thing I would like to talk about is for everyone to remember what is the process FMEA method before we talk about how to make it efficient. Let's consider we focus on the process step which regards the injection, the plastic injection molding of the rear cover. We have a potential failure mode, which is the fact that the rear cover may be dimensionally non-conform, right? So when we do a PFMEA, a process FMEA, that's what we are looking for. Potential failure modes, right? Okay. The first thing we do when we have found a potential failure mode in a process FMEA is we look for the effects, right? So this failure the dimensional problem, what effect does it have on the internal plant, assembly impossible, stop of the line, stock sorting, scrap, etc., on the customer plant, and also on the end customer, right? This effect will give us actually a note from 1 to 10, okay, which is called the severity note, right? S note. How severe is this failure mode, right? When we have looked for that, we look for the potential causes of the problem. So maybe on the injection press, we have a drift of the injection parameters, which generates the dimensional problem, right? So when we have looked for this, we have identified a potential failure, dimensional problem, potential cause, injection press parameter problems. We will try, as a working group, we will try to make sure we have every control in place so that this does not happen. So this is what we do in a Process FMEA. The first thing we look for is how to prevent the problem, how to fully prevent the problem. So try to find something that prevents the drift of injection pressure parameters. Maybe statistical process control or some other kind of automated control of the injection parameters. The second thing we will do is we try to find out how do we actually detect the problem. We detect the drift of injection parameter or the dimensional problem, right? How do we detect? Okay. And the thing we do is, of course, we try to identify first what we currently have in terms of prevention and detection. And as a second step, so as I said, we consider what we currently have in terms of prevention detections. And as a second step, if we consider it's not enough, we will implement action plans. And what allows us to define if it's not enough is actually the occurrence ranking from 1 to 10, right? And also the detection ranking from 1 to 10 as well, right? So we made a ranking of the current prevention from 1 to 10 in terms of occurrence. We make the ranking of the current detection from 1 to 10. And based on the current severity, occurrence, and detection, we find out if our current controls are enough, right? Or if we need an additional action plan. So if the severity, occurrence, detection are too high, let's say, it means the risks are not under control, so we will plan some additional action plans. So this is the way Process FMEA works, basically, in a nutshell, in a very short presentation. And I think it's important to understand that, you know, sometime maybe in your company, when you look at a Process FMEA, you see that the Process FMEA is actually made of many lines, right? So it's a little bit scary to look at these kind of files with many lines. I think it's important to remember the value that we have here, because every line that we have is corresponding to one cause, one failure mode, and one effect. So every line in the file actually allows the company to better understand what could potentially happen, what could be the potential cause and the potential effect. So it is valuable to have all these causes, failures, and effects identified. It's very valuable. So this is what Process FMEA is, right? Now the second point in our webinar is about the savings that are made possible by using Process FMEA, right? So some examples of costs that can be seen on a manufacturing process on the product we are looking at the moment. For example, imagine we have a change on that product. In the previous product, the electrical contacts were mounted manually, right? On the new product, the electrical contacts are going to be overmolded on the plastic part. Okay, so it's a change, right? Another change is on this new design, on this new product, we want to increase the DC power provided, right? So that means we will increase the number of coils, right? But since we don't want to increase the size of the motor too much, we reduce the cable diameter. So we have more coils, but a lower diameter of cable, right? So this is the second change. If we take the first change, one thing that could happen is if we lack experience in injection molding, since the electrical contacts are overmolded, we could end up with an injection press that fails actually to be reliable and stable in terms of the geometric position that is achieved after the overmolding, geometric position of the electrical contacts, right? Due to warpage, we may have bad positions of electrical contacts. This kind of issue, if we think we have it under control, and in fact we don't have it under control, can be costing a lot of money. Here we say, for example, 30% of non-conform motors on 500,000 motors, it makes up to 125,000 euros or dollars. Then we may have a customer that discovers the problem and ask us to absolutely buy cameras that will make 100% control. So it's going to be 250,000 more euros. If we had done a proper job on Process FMEA early on, we would have identified this risk and carried out a redesign of the rear cover with experts in order to optimize the injection process, the overmolding process. We could also have done a DOE analysis. And you see the cost of doing a Process FMEA compared to the cost of the problem. It's a 1 to 100 ratio. And actually, it's often the case, 1 to 100 ratio when Process FMEA is implemented in terms of savings that can be achieved. Another example is if we consider we have a reduction of cable diameter, we may have an issue that we didn't anticipate is the fact that during the industrial coiling process, we may have difficulty to set up the machine and we may have some breakage of cable. It may actually affect dramatically the productivity of the line. It may have a strong impact on the budget of the project. Whereas identifying this issue early in Process FMEA would have enabled to rework the hydraulic module of the machine with the machine manufacturer early on, change maybe the module so that the force is lower, so the cable does not break, and it's easier to set it up. Okay, again, you see a 1 to 10 ratio between the anticipation cost, right, and the problem cost. This is why Process FMEA is really valuable. We may have pollution of the shaft with paint, the same, we have a 1 to 10 ratio between the action that we do in anticipation and the full cost of the issue. So we showed that Process FMEA, when it's well applied, is something that can bring dramatic values and dramatic savings to industrial companies. The question now is, okay, but how do we make Process FMEA more efficient? Okay, so it's clear that Process FMEA is a tool that takes some time. In Process FMEA, as we said, we have many lines, right, that have to be analyzed. So it's a lot of work. So one way to make it very efficient is actually, of course, to use it as soon as possible. Actually, at start of product design, we can already start a Process FMEA. Start as early as possible. But one key idea is to focus Process FMEA early in the project on the most critical OPs. It means the most critical process steps, right? So how do we do that? Well, there is a little tool that can be used which can be quite useful to be able to work on what's critical. So if you imagine the manufacturing process of that electrical motor, we have a lot of process steps. Let me show them to you. We have here the incoming material inspection. We have the storage of material and components. We have one assembly line for the shaft, which is made of 1, 2, 3, 4, 5, 6, 7, 8 process steps. We have one assembly line for the rear cover itself, including the overmolding, assembly of the bearing, etc. We have one assembly line in the plant for the main cover and the magnet assembly. And then we have some transfer operations. So 3 transfer operations, final assembly, crimping, electrical noise test, packaging, expedition, transportation. So in total, I think we have around 25 or so process steps. Okay. So one key when we do a process FMEA is to be able to find out which process steps are critical. So we suggest to use this kind of matrix on our side, which is a prioritization matrix. So you see on each step here, I have a step number, of course. And in this matrix, we have put the different steps numbers in different categories. We have made a ranking in terms of severity of the process step. 4 being the safety or regulatory impact in terms of manufacturing process steps, and 1 being a very, very low impact. And then we made a ranking in terms of frequency of defect or frequency of problems. 4 being some process steps on which we have a lot of problems or that are totally new, and 1 being process steps on which we have very little number of problems, and projects that are in serial life, in production on many similar projects. Okay. So here you see in the colored area, we have made a ranking of the different process steps of the DC electrical motor, right? So what you can see is you have different colors. So of course, everything that is in top right corner is very critical, right? The most critical. And everything in the bottom left corner is much less critical, right? Depending on the color code, you also have some instructions about what to do, right? If you are in the red area, you need to redo entirely the process FMEA. If you are in the yellow area, you'll need to adapt. You can actually reuse a generic process FMEA, but you need to check it carefully, and you need to adapt it to your new product. And if you are in the green area, you can actually reuse a generic process FMEA as a standard design of process, let's say, right? So you have 3 categories. So when you look at the prioritization that we have done, out of 25 process steps, you have around 6 or 7 steps which are in the red area. So it means you have 25 to 30% steps on which you will have to redo entirely the process FMEA because they are important, right? And because they are new. And it also means that you have here around 60 to 75% of your process steps on which you can reuse generic design FMEA with or without making some further check, right? And when we do this matrix with different companies, we find that this ratio is often showing up. 30% of things that are really critical, and 60 to 75% that are lower criticity that can be based on generic PFMEA, right? So that means when you are early on the project, you need to focus on these steps, actually, right? So here, if we focus, and you can change that at each project, of course, we said in terms of changes on that project, we have during injection here of the rear cover, we have an overmolding instead of manual operation. So that means step number 4.4 will actually, it's here in the yellow area. It's important and it's relatively new, right? And then, sorry, it's important and it's relatively new. But actually, this step, in order for it to be considered very carefully, you can, on a new project where you know you have overmolding, you can move it to the number 4 category in terms of frequency of defect, so that it will be treated in priority and with more details. Then we said we have, in terms of the coiling operation here, the creation of the coils, we have a new diameter. We have a lower diameter than before. So step 3.5. Actually, right now it is here in the category 3 and 2. So it means it's in the orange area. I will be able to reuse generic Process FMEA on that step, right? So this matrix is a good way to gain efficiency because we gain time on 60 to 75% of the steps, and we know really well where we need to work early on the project. So this is a way to gain efficiency. And on non-critical operation, we reuse generic Process FMEA. Another way to gain efficiency is actually, for those of you who are in the automotive sector, you may have heard of the new AIAG and VDA FMEA handbook. So this new handbook introduces and reinforces the usage of the notion of product characteristic and process characteristic. And this is really useful when we update a Process FMEA to find out what work needs to be done where on the Process FMEA. So product characteristic, when we have a process step, a product characteristic is an output of that process step. Okay, it's what we want at the end. Maybe at a packaging step, we want to have 8 components in 8 slots in a package, right? That's what we want. Maybe at a machining step, we want to have one GD&T element, right? Correctly done. Okay, it's a product characteristic. And we also have some process characteristics, which are the inputs of the process. Okay, so every input that we need so that in the end, we end up with the right product characteristic, right? So, for example, product characteristics can be dimensions, tolerances, GD&T elements, aspect, integrity of the product. Okay, these are product characteristics. And process characteristics, they can be the training of the operator, the clarity of the work instructions, the temperature of the workshop, the setting of the machine, right? So product characteristic usually link us or give us the failure modes, right? If we want to have the right aspect, one failure is that we don't have the right aspect. And process characteristic usually lead us to the cause of failure mode. Why don't we have the right aspect? Because the machine parameters are not good, right? For example, or because we have a setting instruction of the machine that is not clear, right? Okay. So this is useful to make Process FMEA more efficient. Why and how? Well, if we look at the Process FMEA, I mean the process that I described here for the electrical motor, if we take the 2 steps that have changed, for example, step number 3.5, which is the coil creation, we know we have a lower diameter than before. Step number 4.4, it's the overmolding of the connectors, right? So we know we have a change as well because previously it was done manually, right? So if we go to the FMEA, first, step number 3.5, you see it's in the yellow area. So it means I need to update the Process FMEA. And step number 4.4, it's in the red area. So I need to redo entirely. So if I go to Process FMEA, we have a color code, which shows the same kind of color, right? So if we go here to step 4.4, so injection of injection and overmolding of rear cover, you see it's all empty. Why? Because it's in the red area. So we need to redo entirely this process step. We have an overmolding step, and in the past it was manual. So we need to redo entirely the risk analysis for step 4.4. If we go up, if I go to step 3.5, okay, here it was in the yellow area. So it means we need to update a generic process FMEA. So here I have loaded a generic process FMEA for that step. And as we said, if you apply the new automotive standard, what's nice is that you get here, for the coil creation operation, you get all the product characteristics that you have to achieve. So here you need to create 3 times 50 coils with good cable tension. That's your product characteristics. That's what you want at the end. And you get also one characteristic, which is the integrity of the coil. This is what you want at the end, right? And to get all this, you need to have the right level of training of the setter of the machine. You need to have the right setting on the machine in terms of force and number of coils. You need to have the right method for setting of the machine. And to have a good integrity of the coils, you need to make sure the workstation is clean and you don't have dust around the workstation, right? So looking by line, this product and process characteristic information allows you to find out where you need to work. For example, if you take integrity of the coils, due to some dust present on the machine, this line will not be changing when you change the diameter of the coils. It will stay the same, right? So this line, you know, you don't need to update it. You don't need to go further and review the failure mode, the cause, etc. You know it's not going to change because it regards the level of dust on the machine. The level of dust does not change if we change the coil diameter. But these three here, we have now 60 coils and we have a lower cable diameter. So maybe, most probably, the level of training of operator will not be enough anymore. Instead of having an occurrence of 3, maybe we'll have an occurrence of 6, right? Which will turn this risk here of having a non-conform combination of number of turn and tension due to insufficient training, it will make it higher, right? So we will end up with a risk that gets higher, right? It might be the same for the other lines. For example, in terms of method, we don't want anymore 3 times 50, we want 3 times 60. Actually, it's the same here, I didn't change it, but it's the same. So the method may not be adequate anymore for setting up the machine that creates the coil. So maybe we may have an occurrence of 8, maybe, and test that is also actually much higher than it was before. So if this line was previously a line with a level of criticity medium, I mean, we may end up as well the same as the first line. We may end up with a high level of priority of action plan, high level of criticity, so the need to define an action plan, right? So again, when we have in a process FMEA, we have many, many lines, okay? The fact that we have product and process characteristics accurately defined make us able to find out where we need to work. Actually, we need to work in this case on these items, and these ones actually we don't need to work because the problem does not change when we decrease the cable diameter. Okay. So this is all the new automotive FMEA standard helps bring efficiency to the FMEA process FMEA method. Right. Now let me talk about the last point about efficiency of the process FMEA. One of the issues of the process FMEA is that the way it is conducted in companies is that too often it focuses on things that we already know. So this is why people lose interest in part in process FMEA, because they feel that when they go to a process FMEA meeting, the problems that are discussed are only the problems that they already know, right? And this is a human characteristic, right? Let me present you the story linked to this light post in the night here in the city. Imagine you have two persons sitting close to this light post. Okay, two guys. Okay, one says, "What are you doing here, sir?" to the other. The second one says, "Oh, I'm looking for my car keys because I have lost them." Then the second one asks, "Are you sure you have lost them below this light post?" And the second one answers, "No, I'm not sure, absolutely not. But it's the only place where there is light," right? So it's our human reflex, let's say. We tend to look at what we already know. We tend to focus on what we have already covered by the past and to go back on the issues that we have already seen in the past. But we are a bit under the light post. We don't go and look in the dark, right? So we need to find a way during process FMEA to be able to look in the dark. And the second human trait that we have is that we always, as human, bring more importance to the fact that that reinforce our beliefs than to the fact that contradict our beliefs. So it is more comfortable to us because socially it's better. It makes us more comfortable in our social position with regards to our friends if we don't confront the established order, right? So, well, these two things, we look for what we know and we don't go against our beliefs, are really two issues that need to be addressed when we do process FMEAs. How can they be addressed? Well, there is no secret. The best way to address is to have a strong FMEA moderator that will keep people involved, keep people interested, keep people motivated with the right questions. The second best way to have it addressed is to have management involved. To have a proper change management as well, because process FMEA has to be deployed and the associated change has to happen. To have tools available so that we discover new causes, new failure modes, so that we look at ideas and we get creative when we look for ideas using Ishikawa diagram, 5 whys, etc. To also have a good planning for FMEA, it helps. Regular planning. I didn't say that, but the companies who have the most success with FMEA are the ones who use it every day as a day-to-day tool, right? And the last point is the usage of reverse process FMEA. So reverse process FMEA means going on the field, in the plant, to look at the real problems and their real causes, so that FMEA is based on real data coming from the shop floor, right? So this is maybe the most important advice of all the ones we have made today. It requires organization, it requires competence in terms of moderation, and strong moderation of an FMEA to be able to drive the group and keep it motivated and interested. Okay. So this topic, among others, is a topic that we cover during our training sessions. We provide tailored training sessions available worldwide on a worldwide basis, online. Tailored means they are tailored on your products, on your processes. Of course, we can come to your site as well if you don't want it online. Our training sessions are also technically advanced with trainers who have a strong technical and teaching background. And we include for free as well Of course, we include for free the tailoring, and we also include for free the post-training support. Okay, so thank you very much.